All right, today we're going to be looking at modeling quantities. So our learning target is using proportional reasoning, so we're going to be using proportions to analyze units when solving problems. So we're going to be able to use ratios to solve problems, we're going to use rates to solve problems, and we're going to look at converting units and rates. So what is a ratio? A ratio is just a comparison of two quantities. A proportion is an equation that states that two ratios are equivalent. So if we know that the relationship from A to B is the same as the relationship from C to D, we can write it as a proportion. A over B is equal to C over D. Notice this means that A and C are equivalent to each other and B and D are the equivalent ones to each other. Okay, so if we take a look at this first example, it says you take the measurements shown in the diagram, so we've got all these different measurements. The right triangles created by each object and its shadow are similar. So that means they have the same proportion to each other. Can the tree fall in the house? So we want to know, in other words, how tall the tree is, because if we know how tall a tree is, we can see when it falls. If it's more than 25 feet, we know it's going to hit the house. So I'm going to set up a proportion that it's this side length compared to this side length. So 6, let me get my writing pen, sorry. 6 let's see. Why is my pen not working? Give me a second. So we know that 6, my pen's not working. Give me just a second, see if I can figure it out. Okay, so the side length of the triangle on the side is 6. The bottom of the triangle is 8. And that's going to be equivalent to the side length of the tall one, which we don't know. So I'm going to use X to represent it, over, we know the bottom of this triangle is 30. Okay, so we need to find the relationship. To do that, we can use what's called cross-multiplying, and this probably looks familiar. You've probably seen this before. So if I do 6 times 30, that's 180. That has to be equal to 8 times x, which is 8x. Because they're proportional, we're able to do that. Now, if this was a multiplication sign in here instead of an equal sign, it's not the same thing. You can only use cross-multiplying for proportion when there's an equal sign between it. So now we need to divide both sides by that 8 to get x by itself. When we've got x is equal to 180 divided by 8 is 22.5, and our label would be feet. So if the tree falls this direction, is it going to hit the house? No. It's only 22.5 feet, and the house is 25 feet away. So we don't have to worry about that. Okay, so I want you to try solving a couple proportions. So I'm going to have you do number 1 and number 2. So pause the video, and then once you've tried 1 and 2, resume the video and come back and try them. Okay, so let's take a look at number 1. I'm going to cross multiply. So x times 12 is 12x. 4 times 9 is 36. So I've got 12x is equal to 36 when I cross multiply. So again, we're doing the cross multiplication. And then to get x by itself, we just got one step. We divide both sides by 12, and 12 goes into 36 3 times. So there's number 1. Number 2, again, we're going to cross multiply. 14 times 2 is 28, and 7 times y is 7y. So when we divide both sides by 7, we get y is equal to 4. Good. If you want to try a couple more, you can, but I'm going to go ahead and move on to the next section, using rates. A rate is a ratio of two quantities using different units. You can write rates in many ways. For example, 10 meters per second could be written as the 10 meters over 1 second, like that. Or it could be written with the 10 in front and then the meters over the second. Or we could do 10 meters slash seconds. All of those mean the exact same thing. Typically in the real world, this is probably the one that's used the most often, but all of them are equivalent. You may need to choose your own units to solve a problem. Okay. So it says the diagram shows statistics for a baseball pitcher using rates to compare the pitcher's performance in 2019 compared to his performance in 2020. So if we're trying to figure out how to compare, we can look at different parts of it. So if we're talking about how many strikeouts they had compared to how many walks they had, we can say that they did 100 strikeouts for every 29 walks, and this was in 2019, whereas in 2020, they had 73 strikeouts for every 20 walks. Now, how am I comparing them? We don't put an equal sign between them because they aren't equal to each other. We're trying to compare how this one is compared to this one. So we're actually going to divide those numbers. So we're going to do 100 divided by 29, which is about 3.45 strikeouts per walk. And then for 2020, we're going to do 73 divided by 20, which is 3.65 strikeouts per walk. So both of these are strikeouts per walk. So if we're talking about comparing them, we know that the pitcher had fewer strikeouts per walk in 2019. So if we're wanting them to strike out versus how many times we're walking, this is going to be the better year, right? We want them to have more strikeouts relative compared to how many walks they have. And that's not the only way you could do it. You can compare about how many hits they did compared to how many earned runs. So there's lots of different comparisons. I just chose one of them that you could do. Okay, so I want everybody to try number 7, and then we'll take a look at this one together. So pause the video and come back when you're done. Okay, so the table shows enrollment information for 2 colleges, College A and College B. We're using rates to compare the enrollment. So if we're comparing the enrollment, we could be comparing how many athletes there are to students. We could compare how many students with athletic scholarships to how many athletes are there, or students with academic scholarships to how many students are there. So there's lots of different ways you could do it. So yours may not be the same comparison as mine, and that's okay. So I'm going to compare students with academic scholarship compared to how many total students there are. So the total number of students is 258. And I'm going to compare that to students with academic scholarships, which is 415. All right. And then if I do it for College B, I have 826 with scholarships compared to 7,120 total students. So now I'm going to divide those two numbers. So I got 0.097 for that one, and that would be scholarships per total students. And then I'm going to do 826 divided by 7120, and I get 0.12 scholarships per total enrollment. So you can see College B, it looks like they're giving out more scholarships compared to the total enrollment compared to College A. All right, unit analysis is the last section we're going to be looking at. So you can keep track of units when you're working with rates. All right, so this is going to be our conversions, and we're going to be finding unit analysis. So for example 3, it says we're converting 4.8 gallons to fluid ounces. So I'm going to start with the amount that I currently have. So 4.8, I'm going to make sure and put my label on it. I know that there are 16 cups for every gallon. So I'm going to multiply by 16 cups for 1 gallon. And now I chose to do that because then when I'm multiplying, these two are going to cancel each other out. Those labels will be able to cancel each other out. Technically, this is over 1. But that only takes me to cups. I'm trying to figure out ounces. So then I know that there are 8 ounces for every 1 cup. So now the gallons and the gallons cancel out, the cups and the cups cancel each out, and the only label I'm left with is ounces, which is what I'm trying to go to. So all I need to do is multiply the 4.8 times the 16 times 8. So 4.8 times 16 times 8 will give me 614.4 fluid ounces. So when you're setting it up, you'll need to know what how many of one are in another. And you can just Google those. If you don't know how many ounces are in a gallon, for example, that's something you could look up. If you don't know how many cups are in a gallon, that's something you can just Google. If it's on a quiz or a test, I promise I would tell you how many are in it so that you would be able to do those conversions. And you just need to make sure and set it up so that the labels you're not wanting for your final answer cancel each other out, and only the label that you want for your final answer is the one's left. All right, take a second and write your summary.